Okay, this is a demonstration of the Gearsafe circuit with the new firmware, which decreases the response time of the leak detection circuit, makes it respond even quicker. So to demonstrate it, first we're going to program the Gearsafe. Of course, to do that, we hold down the button while we power up the receiver in the aircraft. Keep holding the button until the LED comes on continuously. Let go. At that point, we're getting now a series of one short flash indicating that it's ready to program the gear down position on the servo. We've got the optional display plugged in, which during these programming steps shows the position of the servo in milliseconds. If we come over here and flip the switch on the transmitter, we can go to the up position, the down position. You'll see the up position is 1.28 milliseconds. The down position is 1.68 milliseconds. So now let's program that. The lower position, we'll just press and hold the button until the LED comes on continuously. Let go of the button. Now we're seeing two short flashes, which means it's ready to program the up position. So we flip the switch on the transmitter to the up position. And as we mentioned before, that's 1.28 milliseconds. We're going to press and hold the button to record that. LED comes on continuously. Let go of the button. Now the display reads 0. We're getting 3 quick flashes. It's ready to program the lower pressure limit. We're going to use this electrical pump to increase the reservoir pressure to that lower pressure limit. So let's set it to about 60 psi. There we go. So I'm going to press and hold the button until the LED comes on continuously. We let go of the button, and now we're getting 4 short flashes, and the 4 short flashes means that it's time to program the leak rate detection. Now if we just simply powered down the system without taking this step, then the leak rate detection system would be disabled. But it's very easy to program it. Basically what you want to do is when you're in this mode, this final programming mode with the 4 short flashes, you just need to cycle the gear through several cycles up and down, and the Gearsafe is going to learn the pressure profile. It's going to look at the pressure profile during those changes and record that, and then use that as a threshold for the leak detection failsafe function. So you'll remember we left it right near threshold at 60 psi, so I'm going to bump that up. And now I'm going to cycle it through several cycles. Okay, now you see a reading of 20. And what that is that's basically the pressure change times 10, so that's 2.0 psi change during a sliding half-second window. That's the way the failsafe works now. Let's go through a few more cycles. Still 20. Okay, so basically now that's the characteristic of the gear cycle right now, and so we're going to record that as the final programming step. We press and hold the button until the LED comes on continuously. At that point you see now it bumped up to 32. Basically it added 50% to that number, multiplied it by 1.5. Now that's our new threshold for the leak rate detection, and that's the value that it will use in this sliding half-second window measuring changes in the pressure. So now basically what we want to do is power down the receiver. Programming is finished. Powering it back up. Now it's in normal operating mode. You'll see that we're seeing one flash, which says that the pressure is at least 10 psi above the set point. If we bump it just above 80, we're seeing 2 flashes now, which means that we're greater than 20 psi above the set point. Now we can cycle the gear a few times, and just to demonstrate that the system won't let the gear stay in the up position above a pressure of 60 psi. That's the most basic fail-safe operation. So cycle the gear up, we're down to 80. Cycle the gear down, 77. Let's just do that a couple of times until we drop near that 60 psi limit. Fairly hard on the landing gear just to do this demonstration, but okay, now we're at 65. 63, 61. So basically that's going to be the last actuation that it allows, because as soon as we drop it, we're now below 60. If I hit the switch, nothing happens. Basically you see the LED on continuously. Now if the gear would have been in the up position as the pressure dropped below 60, they would have automatically deployed. In this case, since the pressure is right at 60, it's not letting us raise the gear. Okay, so now the final thing we want to demonstrate is the leak rate detection. And in order to do that, I'm going to raise the pressure up to closer to the working pressure for this airplane, which is, I always start it off at 100 psi when I take off. Now there's several ways we can demonstrate the leak rate. First, let's raise the gear. So now we've got the gear in the raised position, and the first way we can demonstrate it is we've got a little fitting down here on the fill. It's basically a one-way valve, a self-sealing valve. So if we disconnect that and then reconnect it, basically the reservoir pressure is going to fill the reservoir inside our little electric pump. It's going to cause a rapid drop in pressure, but the pressure is not going to drop below our 60 psi, but the gear is going to deploy anyway because it detects that rapid loss in pressure. So here we go. We see the very fast LED flashing indicating that that was a leak rate event. Even though our pressure is still at 86, the gear was deployed because of the rapid pressure drop that was significantly exceeded that which we recorded during the programming step for normal gear operation. So I'm going to put the switch on the transmitter back to the lower position. Now you see we're back into normal mode of operation. We've got our two flashes indicating that we're more than 20 psi above the set point of 60 psi. I'm going to bring now the gear back up, the pressure back up to operating pressure, raise the gear. And now another demonstration we can do is we've got a fitting up here which is on the pressure line to the up position on the gear. If we disconnect that, we're going to get a rapid pressure loss. Very similar. So let's say sometime in flight we lose this particular hose. Okay. So again, as soon as the gear deploys, since I was disconnecting the high pressure line for the up position, as soon as the gear goes into the down position, the leak stops. So we had a rapid drop in pressure. We know that because we've got the high speed flashing. The pressure only dropped to 88, which is well above our 60 psi, but it's still deployed because of the rapid drop in pressure. This is the leak safe operation. So I'm going to now reconnect this hose. Okay. Then I'm going to put the gear back down into the lowered position. There we got our normal flashing. Then I'm going to bring the pressure back up to normal operating. And at the final demonstration, this is going to be the most stressful demonstration. Basically, I've got this little stub here, which is connected to the line right near the pressure tank. So this is going to be the most stressful demonstration. I'm going to come in with a pair of scissors, and I'm going to just cut that line, and we're going to see a very rapid pressure loss. In fact, you're going to hear it, I think, in the video, and what we'll see is the Gearsafe leak rate detection kicking in and getting the gear, oops, make sure the gear's up. It's going to get the gear down before the pressure runs out, saving allowing us to land with gear down. So here we go. Ready? Okay. So there we saw it. We've got the fast flashing on the Gearsafe unit indicating this was a leak rate event. We'll try to play it back frame by frame so you can sort of really watch the pressure drop and just show that the gear deployed well before it hit the 60 psi limit. But really the most important thing is we were able to cut a line, a primary line right near our pressure tank, had a rapid depressurization of the system. We still got the gear safely down, and we can land the aircraft safely.